So we're basically going to do the same thing that you saw with the squares and the rectangles. The only difference is we'll be taking some different shapes. Sometimes we'll cut it so that everything is a triangle. Either an equilateral triangle or an isosceles triangle, that's also a right triangle, or sometimes we'll do semicircles. The idea is exactly the same. For these cross-section questions, your volume's always going to be lower bound to upper bound of the area of one of those cross-sections. And again, you have to be careful to see, are they doing it towards the x-axis, or parallel to the x-axis, or parallel to the y-axis? Some of these formulas are a little bit trickier. Did you know that if you have an equilateral triangle and you had to make the area based on S, you could figure that out? What's the area of a triangle normally? Base times height. What's the problem? Okay, the S, that part is going to be whatever your function is. Your height here, we would have to figure out in terms of S. But since it's an equilateral triangle, this would be 60 degrees. This side over here is also S, and this side over there is also S. And we need to find out exactly how high that is. Well, if I did, I mean, you can just memorize this formula if you want, but I find that the problem is I don't memorize this formula, then I have to figure it out on the exam. And if I had to figure it out on the exam and I drew an equilateral triangle like this, I know that sine of 60 degrees from my unit circle is root 3 over 2. And so, if that's root 3 over 2, well, root 3 over 2, in this case, has to equal opposite over hypotenuse. And so x is root 3 over 2. Now, why do I have, I'm feeling like something isn't quite right, because if I now do base times height, I would have root 3 over 2s squared. Where's my 4 coming from? It's 1/2, right? Area of a triangle is 1/2 base times height, so there's that extra 2 on the bottom. And we get root 3 over 4 s squared. Now you can just remember that formula, or if you got stuck, you could refigure it out. Because our area of a triangle, this one, I don't think you'll forget. 1/2 base times height. The base is s, that height of x, you could use your unit circle to figure that that's root 3 over 2s, and then we get our area. And this is just saying that where s is f of x minus g of x, that's depending on which functions is your top function minus your bottom function. So, a region is bound by y equals x squared and y equals square root of x. These are the exact same question that you saw on the video, but this time we're going to do equilateral triangles perpendicular to the x-axis. And just like the video, whichever way they do perpendicular, I like to draw that line so that you make sure, okay, if I'm doing it that way, perpendicular to the x-axis, that means I'm starting at 0 and going to 1. So I got my root 3 over 4. My upper function is the square root of x. My lower function is x squared. That's all going to be squared. And if you type this into your calculator, you will get 0.056. So again, what's probably the hardest part is knowing your formulas. Squares, super easy formula. Rectangles, not bad, although we saw some questions where they could make it weird rectangles, but again, not too bad. This one is a little bit tricky. The next one we're going to look at is isosceles right angle triangles. These are super easy. Because if it's an isosceles right angle triangle, you know that there's a 90-degree here. This side S is also represented there by that side S. So the area is 1/2 base times height, which just becomes 1/2 S squared. So we got that same region as we had before. Again, I read that it's perpendicular to the x-axis, so I draw one cross section there, and I'm going from here to here if it's perpendicular to the x-axis, because I would add up all of those triangles going from left to right. And the setup is the same, except the formula is what's different. A little bit of drum roll. Last topic of the calculus part, semicircles. So now we need to figure out what is the area of a semicircle if that bottom cross section is S. Okay. Now, you know, a whole circle would be pi r squared. Does it make sense that a semicircle would be half of that? And if S was normally the one function minus the other function, does it make sense that in the formula where you need the radius would equal that divided by 2? So here's our first example. Same idea. Again, we're still perpendicular to the x-axis, but now each of those, if you cut them out and visualize them, they would be semicircles. So we're going to add these all up. We're still going from 0 to 1. 1/2 pi r squared, but now our radius is the top function minus the bottom function divided by 2. If this was non-calculator, you could actually do it if you squared that out and did each one separately. Doesn't sound too enjoyable, but could be possible to do. A solid has a circular base of radius 4. So I put a circle with a radius of 4 on a graph. That's the base. Every plane section perpendicular to a fixed diameter is an equilateral triangle. In this case, it would not matter if you thought perpendicular this way, because then this would be your fixed diameter, and then moving along the x-axis, or perpendicular to the y-axis, because it's a circle and it's symmetric. You could even pick a weird diameter, but I wouldn't suggest that, because that complicates it more than it needs to. So this is what we have. Now, each of these is a perfect equilateral triangle. Now, this is going to pose some problems because a little bit about this equation. What are we going to do? Well, we could have this as a top equation. This is a bottom equation. We need to come up with the equation of a circle. Equation of the unit circle is x squared plus y squared equals 1. This part in the equation of a circle is always your radius squared. So if you're centered at 0, 0, x squared plus y squared equals r squared is your equation of a circle. If I got y by itself, technically there would be a plus or minus there. And the positive one would be the semicircle on the top. The negative one would be the semicircle on the bottom. Here's our equilateral triangle. This length right here is 16 minus x squared, because that would be half of that base. The whole thing, you would have, obviously, this part here, another 16 minus x squared, so the whole base would be 2 times that. There's our area formula for an equilateral triangle. That root 3 over 4, 2 of those root 16 minus x squareds, all squared. If you squared that 2, you'd get a 4, that would cancel out, so I could write it just like that. One idea you could do. One idea you could do is you could just do the top half of half the equilateral triangle and then double it. You could take the whole triangle and do it from -4 to 4 as well. Halving it and doubling it really doesn't do anything, does it? They would just cancel each other out. So I'd probably just go from -4 to 4 of the whole triangle. But either way, you will get 147.802.